first problem is this one right here on top. I'll just circle the bullet point right there. Find the area and perimeter of this square, and they give it to you right there. Now, it has been a long time since we've talked about area and perimeter, and it's something in another few days, probably after spring break, actually, that we'll pull it back up, and just because we need to practice it a little bit because we did not spend much time on it when we first got to it. So I know it's having to think way on back. I just want you to do the best you can. So this is two different problems right here. You're finding the area, and then you're finding the perimeter. So think about it. Do what you can do, and then we'll talk about it just for a second. I want to see what you remember. Let's see what you remember. Be two different math problems. Seeing a lot of movement with the marker, so we make sure you write down your math problem and your answers.
I'm already done.
They're just being awfully still this morning. All right, I'm gonna flip. There's just not a lot of room here, so let me do this. All right, there's a square that they give you. Area and perimeter of this. I'm just rewriting the problem for you. Okay? Alright, so let's talk about the area first. What does that area equal? How do I find the area of something? And I know that we haven't done just straight area for a very long time, but it is sort of connected to the area model that we've done lots of times. Okay. So what are we remembering?
A
Let's wake you up.
A square is 20. A square has the same length on every side.
Okay, that is a super important piece of information right there. Okay, because if you were looking at that going, they've only given me one number, something's missing. They told you, though, that it was a square. So if it's a square, every single side is the same length. Okay. All right, but it still doesn't answer my, pardon me, still doesn't answer my question. How do I find the area? Yeah. And can't we do that now? Yeah. Okay. Because what the formula is the length times the width. Okay. So the area would be the length, there's an L, times the width. That's just kind of like, abbreviations for those things. So the area would equal 22 times 22. And you can go over somewhere and turn that around. 2 times 2 is 4. 2 times 2 is 4. Put your 0. 2 times 2 is 4. 2 times 2 is 4. So we've got, so our area would equal 484. And how do we label that? Did they tell us a unit of measurement? No. So what do we do when they don't tell us? Yeah. Square units. Because whatever unit it is, centimeters, miles, meters, it would be square meters or square centimeters or square. Okay. So we could write SQ for square and then just the word units because we don't know the unit, so we're just going to put the word units. Okay. That's what you do when they don't tell you, which thing they're measuring in. Okay. All right. Ready. Let me put your lunchbox here and just leave it there for now. You want to grab it and put it on the shelf, or you can put it with your backpack. It's fine. All right. So that's area. The length times the width. You take the number that's here times the number that's here. And how did we know that number? Because it's a square, all the sides are the same. Okay, so let's leave area and go to perimeter. How do I find the perimeter? How is it different than area? Okay, how is it different? Sometimes we get those mixed up or can't remember which is which. Reagan,
You
add what?
the body side.
Okay, the perimeter is how long it is all the way around the outside of an object. Okay, so again, I would need the information about the square, very important, because if I know this is 22, then all of these are 22 if it's a square. So I need to add those all up. Brandon, I didn't see you adding. I saw you doing something else on your board. What were you doing? Multiplying. Because now we know that's a lot quicker. So I could do 22 times what? 4. Okay. 22 times 4, which gives me 88. So my perimeter, you could have added it all up. No problem there either. Okay. And so my perimeter is just 88 units, no square units in perimeter. Square units happen with area, not perimeter. Okay. All right, like I said, in another good handful of days, we'll pull this back out, both of these, area and perimeter, and we'll make sure we've practiced it. It's been a while since we've done this. All right, since we're on this blank board, I'm going to stay here for just a second. That's what I need right there. Okay. Here is a question. We'll just do it during our review time. Here. Okay. I'm really going to try to make your brains work. All right, we've been working with angles and measuring those angles, right? All right, raise your hand if you remember how many degrees are in a whole circle. Yeah. 360. Okay. 360 are in the whole thing, right? So what if I had an angle that was only 1 degree? Remember they showed us a 1 degree angle in that, okay? And it was so tiny you could hardly see it was even open. Okay. How can I write the fraction of how many degrees that is? Think about how many degrees are in the whole thing. And we've got a 1 degree angle. Yeah. 1/360. Now, it is rare to have a denominator, that we are going to work with a denominator that large. But because we're talking about how many degrees are in the whole circle, if my angle were just 1, boy, I don't even know if I could draw that. I mean, that's probably way more than 1 degree.
Like 2 probably.
Yeah. But if that was a 1 degree angle, here I'll label it so we can all pretend that I drew it perfectly. If I had a 1 degree angle, if I were asked to write that amount of degrees as a fraction, it's only 1/360. Okay? Say it one more time.
No matter what, how big or how small the circle is, the fraction will always have 360.
It will. So I'm going to imagine that that's close. I don't think it's perfect either. But let's say that this is a 45 degree angle. How would I write that amount of degrees as a fraction? This is 1 degree as a fraction. How would I write 45 degrees as a fraction? Let's put everything right. Okay, what do you think?
45, 360.
That's exactly right. All that fraction is, guys, remember back to our fractions, is how much I have over how much is in the whole. So 360 degrees is what it takes to have the whole circle, okay? If the angle, the top of the angle went all the way around, full rotation, however you want to say it. But if my angle is only 45 degrees, that's all I have. I just have that much of the circle, okay? So every now and then something will jump out like this, and what we're doing, it might show up somewhere, and I just want to make sure that we can relate fractions to a lot of things we do, okay? Because this is still a part of the whole circle. So when you're dealing with parts and then whole pieces, there's fractions, okay? All right. Let's just clear off our board. I think that's the last like review kind of thing we're gonna do. I don't know, keep it out. We might use it. Just push it aside for now. Okay, I want you to try something. I want you to stand up right beside your desk. Let's see. Stand on the left side of your desk, like on the side where you get up. All right. That way everybody's kind of on the same side of their desk. Okay. If you'll face this way, and some of you are turned just a little bit, but have your body turned like to this wall. Okay. All right, y'all with me? Okay, so I'm going to give you some directions and see if you can follow them. Okay. All right.
So this is like something.
No, just listen. No. Make sure you're turned because that's important. All right. So I want you to right now make a 180-degree turn. You're not walking anywhere. All you're doing is turning. Make a 180-degree turn. And I want to see if you know which wall you'd be facing if you did that. And it's okay if it's a guess. You're starting facing me. If you were asked to make a 180-degree turn, and you could turn either way. All right. Now, with a 180, everybody should be facing the same way. All right, don't move. Once you've turned, don't move be still. All right, so would everybody keep where you are? I just want your head to turn right now. I want you to look at Faith, Mason, and Ishmael. Y'all are all facing that wall, correct? And Isabel. Right, they have made a 180-degree turn. Okay. All right, stay where you are. Everybody face the same way that Ishmael is. Go ahead and turn that. Okay. All right, so Valerie, turn all the way about. There you go. Okay. Make a 180-degree turn. Turn 180 degrees again. Okay. Because I'm wondering if somebody gave you these directions, would you know what you're facing? And that was correct for everybody. Okay. 180 degrees is going to send me in the opposite direction. Okay. And if I did it again, I would be back to where I started. All right. Stay where you are. You're facing this way. I want you to make a 360-degree turn. Okay, and that should put you all the way back to where you started. That's a full circle. Okay, listen. I want you to make a 90-degree turn. Now, don't look at anybody else because they don't know if they're right either at this point. Make a 90-degree turn. Where do you think you would be? And if you turn to the other, the opposite direction, you can do it either direction. Okay? All right, so I'm looking right now. Isabella, which way are you facing? Which wall are you facing? Just choose one. You're not facing this way anymore because you turned. Okay? So I'm looking. Are you facing this wall? Okay. And all right, everybody did that correctly. Now, if you're looking at Bailey going, she didn't. She did. She just turned the opposite way that everybody did. Okay. All right. So make a 90-degree turn again. No, it's not around or down. It's a one more fourth of the circle, so to speak. Yeah. So if you're still turning that way, you'd be turning You'd be back there by now. All right, make another 90-degree turn.
To the right.
We could turn this into the angle dance, yeah. All right, make one more 90-degree turn. And you should be back where you started because we did it 4 times. So that 90-degree turn is like, think of yourself as a circle or maybe standing in a circle. And you turn that 90 degrees. I turned a right angle, didn't I?
This way.
Another 90 would put me here because that's 180 total. So I turned the opposite. Where did I start? I lost my place. All right, there's my 90. There's my 180. My other 90, y'all did this. That would be 270 if I added 3 90s together. And then the 360 if I added 4 90s together. All right, good job with that. Have a seat.
We need to make an instant video.
Yeah, that would be fun. Sometimes you're asked in a question, you might see this like, Susie was driving in her car. She was driving towards Hall's farm. She made a 90-degree turn to the right.
And 100.
Just listen, and then went a little ways, and then made another 90-degree turn to the right. What is she now facing? And you might be looking at a picture, and they ask you, what is she now looking at? And so it's, can you turn the right number of turns? It's just kind of a fun way to practice angles. You don't think of angles happening that way, but it's still part of it. Okay, today, and I'm saying this, we're just about to jump into our new stuff. If the rain gets harder, if the power goes out, I said this the other day, we got it. We're good, okay? It's just a rainy, stormy day. You may hear thunder at times, but don't let that bother you, okay? All right, I am not going to follow all of this. I'm going to jump us right here. Okay. I can't remember if I did this just in second period or if we talked about it just for a second yesterday in here too. I think we did. Anyway, let's go back to right here for a second. All right. Now, if you want to use your board, I don't want you to draw the bubbles every time, but if you need the board to do any math to figure this out, that's okay. And of course, you can't see what I'm talking about. There we go. Okay. So we're looking at a number bond. We saw some of these yesterday. If this is 90 and this one's 15, what would have to go in the other bubble? If you need to do an addition or subtraction problem to figure that out on your board, that's fine. But we're not going to draw the whole number bond every single time. Okay. What would go in the other bubble? Now, if you can do this as mental math, that's fine too. Okay? Ishmael, what would go in the other bubble?
No, I disagree. No.
Okay, I'm hearing some disagreement. I was going to check it on the side, but let me. Yeah. 75.
Let's go. I agree.
All right. Okay. Guys, when you're doing that, agree, disagree. It's quiet. Okay. But well, this is a real easy mistake to make. Okay. So if you think it's 85 at first, ask yourself, okay, how much more would I need to get to 90? It would just be 5 instead of 15. Okay. So 90 take away 15, if you're wanting to be sure, would be 75. Okay. All right. Let's try another one. Ooh. Got 180. We break it into pieces. We got 170 and what? And just 10. You just need 10 more right here. Okay. It's 10 and 170 is 180. Okay. What if we did this one? Mike could do it. Mental math. Might need to write it down. No problem if you need to write it down. Will, what do you think? 95. If I pretend that's 80 for a second and I subtract it, I'm at 100. But then I need to take away that extra 5. So 85. Okay? what if we put, I don't know, the bubbles are on top. I know it's going to mess somebody up. Is it? No. Okay, this is just a number bond. We can put the bubbles on the side, the top, the bottom. All right, you might remember these special numbers. You might not have to do mental math here. Okay, what do you think?
180.
Not 180. That is one of our important numbers, but it's a different one. Yeah.
70.
No, because 70 and 90 would be 160. So we need more than that. Yeah.
So
No, but I know some of y'all are so close. What?
270.
270. Okay. 270. And 270 is one of those numbers that I hope you will eventually remember. 90, 180, 270, 360. That's where we are when our angle opens. When we've done 3 90-degree angles, that's 270. Okay? All right, let's just do one more. But are you listening? Bailey, what's missing? 90. Okay. So if we've got the big piece this time, we've got the 90 left over. All right. Once again, why do you think we are working with numbers like 360, 180, and 90 when it comes to these number bonds? Mason, what do you think?
I think because we need to know what degrees our angles are.
That, anybody want to add anything to that? Yeah.
All those numbers are like our benchmarks.
They are, yes, absolutely. They are like our benchmarks. And what we're doing today, your benchmark numbers are going to be very helpful. Now, if you're not remembering these, you don't have them all in your head, it's okay. You know, but it is something to try and start remembering. Okay. So if we have an angle that looks like this, all right, you can even let that little bitty arc in the corner that's shaped like a square help you. What does it mean when that little arc down in the corner is shaped like a square? I mentioned this several days ago. If the arc in the corner is a square instead of a rounded arc, it means what? What do you think? It's a 90-degree angle. So I don't even have to have the number 90 on there. I just know that's a right angle. That is 90 degrees. Okay? Don't have your eyes, guys. Okay? So if this whole thing is 90 degrees, right? And we have a piece of it, can we figure out what the other piece is? If we know what the whole thing is, and somebody gives you a piece of it, like we know that this piece right here is 60, because they tell us that. But then there's this little X, and that little X is just there to say, hey, you don't, what am I? You don't know what I am, so let's figure that out. So what would X be if this is 60? If I have 90 and I take 60 away, what's left over, everybody?
30. 30. 30.
Oh no.
Did you say 4?
Oh! All right.
And I got red on.
Let's try this one more time. So if the whole thing is 90, and we know part of it is 60, we take that 60 away, we have, everybody,
30. 30.
okay. Yeah, 30 degrees. So this is 30, and then it, right here it's saying X is, there's that blank I'm telling you. See, an X is just like a blank that you're trying to fill in. Okay? I'm putting letters in your math, and don't get mad about it.
Oh, no.
Okay.
She's gonna turn into Hulk.
That's right. All right.
Oh,
No whining. No whining. Okay. Or I'm going to have to draw a box on the floor and put you in the patty box.
Please,
Okay.
please.
No patty box. No patty box people in here. All right. Let's see how this works with a different total. Okay? All right. So what can you tell me about this picture? Let's pull out what we know, because if all of a sudden you open your problem set and this is on the page And you're looking at it like, you know, what do we know? What's our information we already know? What's one thing? Okay, so the whole thing is 180 degrees. How did Will know that?
Because it's flat.
Because it's what? Flat. Because it's straight. Straight angles are 180 degrees. That is a flat, straight line. You just automatically know. It's 180 degrees all total. If everything is there, if all the pieces are there, it's 180 degrees. All right, what piece do we know? Look at the picture. What piece, Brandon, do we know? What piece did they give us? How big is it?
132.
They gave us how big this piece is right here. So if you know the total and you know one of the pieces, can you figure out the other piece?
Yes.
What operation are you going to have to do?
Add, subtract.
Subtract. Because we know the total, we're going to subtract what we know, the piece we know, so that we can get the missing piece. So on your board right now, I want everybody to figure out what number goes here. What would be, like I could take that X away and put in the correct number. Okay? What would it be? Give me a second to figure that out. This is where we're starting to mix our numbers and our operations and things with our geometry. Okay? Alright. Ishmael, what'd you get when you subtracted 132 from 180?
48.
Okay, he got 48. Did anybody else get 48? You agree? Let's see if I agree. Let's see. Yep, I totally agree. So this is 48. You see that little degree sign? How little it is? It doesn't look like a period. It's not that little. And it does not, please hear this, it does not look like a 0. Be careful because sometimes when we're in a hurry and we make that, I've seen people's degree sign almost be big enough to be a 0, and then it's like, did they mean to do a degree sign or do they think that's 480 degrees? You see what I'm saying? So I don't want to think you're writing a different number.
You want to make it big enough to see, but you don't want to make it.
Absolutely. Okay. Ooh, look how fancy we're getting here. Now we have an angle in this figure. We have several actually. What is our total? Okay, let's 180 because this again is a straight angle. But what's different this time? Yeah.
There's two spaces that has numbers and there's one space that doesn't.
It's cut into 3 pieces this time. Is this really going to change much?
No.
No, you might have to subtract twice, or hold on. You might have to subtract twice, but what if I didn't want to subtract twice? What could you do? You could add these together and only have to subtract once. Okay, some of you like that much better. 30 and 45. What is that going to be together? Excuse me, together?
75.
75. This all together is 75, so I'm going to subtract that from 180. Okay, go ahead and do that. And you may get to where you can do some of these mental math. Especially if it's a multiple. What you got, Brandon?
105.
105 potatoes. That's what the answer is.
Potatoes.
Right? 105 cats.
I'd rather have potatoes.
105 tomatoes.
105 baked potatoes.
Well, oh, okay, I'm with you on that one. 105
degrees.
stars. Okay, 105 degrees. Correct answer. Just making a point. We did need to put that. 105. 105 pizzas? Is that what you're saying? Okay, we're done with math. Let's go eat.
Yeah. Yes,
Okay.
for real.
All right. We are almost done. Because look at my very next slide. What is that? That's our problem set. Okay. This is nothing more than adding up the parts to equal the whole. Okay. It's really not. difficult. And then, like, another day or so down the road, we'll grab our 360 and do some of those. We won't get quite that big today.
I don't get my circle tracker.
You don't need it. Now, all right, Martin just brought up a good question. Are we going to get our protractor? Because, you know, I could just sit here and measure those angles, and I wouldn't have to do, well, couldn't I? Couldn't I just measure them, and then I don't have to add or subtract? Yes, you could, but hold on. Yeah, good try. But what if you don't have the protractor? And this is what
You're gonna have to do.
This is what we're seeing today. We're seeing that you can figure out the angles if you know parts. Then you can figure out what you don't know, even without the protractor. Okay. All right, let's go ahead and take our break. Put your boards away.
What we're doing.